Hola a todos, buenos días, buenas tardes, buenas noches, donde se encuentren. Estamos en nuestra última sesión de la jornada del JConf. Aquí nos acompaña, como siempre, colaborando con la comunidad Reza Rahman. Reza, bienvenido una vez más a una nueva edición del JConf. Al que aún no conoce a Reza, lo cual no creo, Reza es mundialmente ya conocido a nivel, en todo lo que es la evangelización de Java, ¿no? De los principios, las especificaciones de Java. Reza es Principal Manager, Program Manager, sorry, para Java en Azure, en Microsoft. Él viene trabajando hace muchos años con las comunidades de Java y también con el ecosistema de Java que se desarrolla en Microsoft. Reza es eh, oficialmente Java Evangelista y Tecnología, o ha sido, digamos, Java Technologies en Oracle. Actualmente ha hecho varios libros, es frecuentemente speaker en diferentes JUCs, inclusive en las charlas worldwide a nivel de Jakarta One, de Nexus, Java One. Y esta vez viene a compartirnos una charla interesante que es lo nuevo de Jakarta EE 11. Hey, Reza, thank you to join us.
Oh, no problem. It's really good to be here, and I wish I was here talking to you in person, but yeah, that's not the case this time. But regardless, I'm always happy to see you guys, and thank you for having me. So yeah, after that long introduction, I'm not going to bother introducing myself too much, except to say, actually, I'm not here in my day job capacity. A majority of this talk is going to be from a Jakarta EE ambassador's perspective, and that's why actually I'm using the Jakarta EE ambassadors template, and also in my speaker bio, it has more of a Jakarta EE ambassador's angle. I'll talk a little bit about what exactly that means in a moment. But if you haven't heard of the ambassadors before, I'll make a brief introduction in due course of this presentation. And in fact, the beyond part of the presentation actually has to do more along the lines of the ambassadors. So just to reiterate a little bit more beyond what Carlos said, primarily this talk is about what is in Jakarta 11, but actually we'll be talking a little bit more beyond that, because obviously the world doesn't stop with Jakarta 11. There's a lot more to be done in the Jakarta platform. So we're also talking a little bit about what may be beyond Jakarta 11, Jakarta 12, and so on, and also how you can help contribute and move some of that work forward. I think that's always something that would be really good to see, especially from this part of the world when that's possible. So I'm going to do a few introduction slides for those folks that are really not familiar with what has been going on in Jakarta EE. A little bit of a background, but not too much. Primarily, we're going to be focusing on the core content here. So I'm going to breeze over this part as quickly as I can. So if you don't know what Jakarta is, it is basically the newest rendition or the transition of the technology formerly called Java EE. It moved from the JCP, where the Java development still occurs, to the Eclipse Foundation a few years ago and had to be rebranded as Jakarta EE in the process. The difference between the JCP is that it is completely open source. All of the IP is owned by the Eclipse Foundation. Everybody sort of has an equal say, whereas in the JCP, Oracle has a little bit more of a say than anybody else. Everything is open source, including the TCK. The TCK for Java is not open source yet, and it didn't used to be for Java EE, but in this case it is. Now, of course, we believe that this was a very important transition, and really in the history of in any major technology, something moving more into a more open space and still remaining alive, it's a pretty rare thing. So this is one of the biggest technology transformation that has ever happened, and frankly, it's all of our responsibility to make sure that it succeeds. But the good news is that one of the things we're concerned about is how many stakeholders were we going to retain in the process of the transformation, and that has by and large actually remained intact. So all of the key stakeholders like Oracle, IBM, Payara, all the folks that had Java EE runtimes continue to have Java EE runtimes, Jakarta EE runtimes, and actually we've added a few new runtimes in due process as well. But most interestingly, actually, there's more stakeholders now. people like Alibaba just joined, which is really kind of a very nice thing. And of course, my own company, Microsoft, we joined in the Jakarta EE process to help drive all of this forward. Now, one of the things, and that is where the ambassadors part and the you part comes in, is that one of our hopes in doing all of this was actually to make it easier for people to contribute. Because as an individual, it was not that easy to contribute in the JCP, particularly if you're going to have a key role in driving a specification. So people like Otavio Santana, for example, he had a very active role in moving one of the key specifications in Jakarta EE forward, Jakarta Data. That simply would not have been possible in the JCP days in that manner. So one of the key things that we want to accomplish is have more contributions from people like you, and I believe that is very, very possible as long as you have the willingness to do it. So if you want to find out more about Jakarta EE, obviously the place to start would be jakarta.ee. Even the official tutorial was up to date, and it covers Jakarta EE 10 in a nice way as well. So definitely, if you want to learn more, lots of resources to do so. Now, one of the things that I'll also address is whenever I have conversations, especially with folks that are sort of have this sort of J2E perspective on the technology, they often tell you, oh, is this relevant anymore? And the truth is, it very much is if you take a look at an objective look at things. So first and foremost, I see this in my day job in Azure. Really, quarter to a third of workloads that we come across, and in general that are out there, are running on some kind of Jakarta runtime, whether it's Wildfly, Payara, Blastfish, what have you, even old school WebSphere, WebLogic. All in all, still a very large footprint globally in terms of all of these workloads that still depend on this technology because they're running on a Java EE or Jakarta EE compatible runtime. Now, granted, one of the concerns that I have is a lot of these are actually legacy workloads. We want to see more new applications that are using Jakarta EE as opposed to just the applications that have been around for, let's say, 5 to 10 years. Aside from that, now let's suppose you don't use any Jakarta EE compatible runtime, or you're using something like Spring Boot or Microprofile or Quarkus or what have you. The reality is a lot of these technologies actually have a transitive dependency, are ultimately dependent on at least one Jakarta EE technology or more, whether that's Servlet or JPA or JTA or JSF or what have you, right? So for whether you're using Tomcat or Hibernate or ActiveMQ or ResTZ or Quarkus, Microprofile, Spring Boot, all of these technologies ultimately depend on Jakarta EE some way. In other words, there's not many enterprise Java developers, at least, that are not using Jakarta EE in some way, right? And you can see this. You can see some of this data when you look at something like, for example, the Jakarta EE developer survey from the Eclipse Foundation. You can take a look at that, and you'll see that it is very far from sort of an irrelevant technology, right? Even though maybe there's not as many new applications as we would like to have been developed in this and developed and using Jakarta EE compatible runtimes, is still a very important technology. So you even in this talk, if you're not using any of these applications for us, you'll still see that a lot of changes are actually relevant to you. Okay. Again, I'm going to briefly breeze over this. This is a technology that has a very storied past, right? It started many, many years ago. In fact, I have been involved in this for almost 20 years now. I'm going on 20 years, all the way back to being a user in the J2 era, and then beginning to be a contributor in the JCP, Java E5 onwards. It's been a long journey for me. Obviously, the Eclipse Foundation transformation happened. The transition happened from Java EE to Jakarta EE8, and those are basically binary compatible. The only thing that happened was moving the technology from proving that the technology can move seamlessly from the JCP to Eclipse Foundation. And then 9.1 and 9.0 are basically transitional releases, right? So the primary thing that happened there is moving the namespace from Javax to Jakarta because of trademark reasons. But that's done now. It's been a few years since that's been done. And I think a lot of you probably have dealt with this transition. Even if you're using, let's say, something like Spring Boot, you may have had to deal with the associated changes because of the transition of the namespace in the Jakarta E9X timeframe. And then finally, you have new updates, some new changes that took a long time. Actually, there was a gap period where there wasn't any real technological changes in Jakarta EE, and that's finally changed with EE10 and now with EE11. Now you have a little bit more API changes. In this case, in Jakarta EE10, you actually had the first new specification that was added ever since the first one since Java 8. So it's been a really long time, namely Jakarta Data. And of course, we're going to talk a little bit about that as well. Aside from that, I also want to point out that Jakarta EE, like I said, powers a larger ecosystem, right? So there's actually, aside from the changes that are happening in Jakarta EE, if you look at things like Helidon or Quarkus or Microprofile, there's also a lot of innovation happening around those places as well that ultimately will probably wind up in Jakarta EE in some shape or fashion. So aside from the changes in Jakarta EE, always interesting to see the evolution of the landscape around it and the ecosystem around it as well. Okay. Now let's begin to get into the meat of the matter. Hopefully, I've established enough of a context for you to get a feel for what we're talking about foundationally, if you haven't kept up to date for a little bit. So the main thing I'm going to introduce is the Jakarta EE ambassadors. So we actually had a very active role in catalyzing the move from the JCP to the Eclipse Foundation and from Java EE to Jakarta EE. I hope it has been for the best. But since then, we've renamed ourselves from the Java EE Guardians to the Jakarta EE Ambassadors. Foundationally, it's really just a bunch of different people that are interested and see the importance of this technology, trying to move it forward and trying to keep it relevant and alive by evangelizing, contributing, writing about it, blogging about it, so on. Right. So if you're interested in it, please take a look at it. There's obviously a website for the Jakarta EE Ambassadors. You can check that out. There's also a X and now Blue Sky handle. So if you want to stay up to date with what the ambassadors are up to, you can do that way as well. And in general, we try to basically tell you what is going on in the ecosystem as well. So one of the things that we did, and we did this fairly early, actually in the Jakarta EE9 time span, is come up with what we call contributors guide. And really what this is it basically tells you here are the possibilities, here are the things that we as ambassadors believe are important for the Jakarta EE platform to do in order to remain up to date and competitive. And here's how you can go and help contribute some of these things. Now, frankly, one of the impetuses for us doing this is a lot of these items that are in the ambassador's contributor guide actually are things that are well understood, that have been discussed in one way or the other, all the way back to the JCP days, sometimes as far back as the Java EE5 days. And we were concerned that with the transition from Java EE to Jakarta EE, are those things that are already been discussed as things that are important to consider doing, are those going to be lost? So we wanted to document all of those. And that's actually one of the reasons why we have these contributing guides. We had one for EE10. We also have one now for EE11. That's the URL for it if you want to check it out. And I will share the link to this deck as well, so you can check out this deck later on as well. So if you put sort of Jakarta EE10, so one way of looking at Jakarta EE10 is in terms of that contributor guide. So remember, we had a Jakarta EE10 and Jakarta EE11 contributor guide. And what you can do is you can list out the changes that we envisioned as being important in the contributor guide, and then take a look at what actually was delivered of that in Jakarta EE10 and what is sort of on the way. So I won't go over this in great detail. Basically, I would say Jakarta EE10 overall did a decent job of addressing some of these things. It's all in all not so bad, right? I would say it's a decent release, Jakarta EE10, that had some important changes actually, but there was a lot that was not done, right? That was sort of identified gaps that we have, and some things that were sort of in flight, things that could be done. So you can look at it, Jakarta 11, in the same context, in the same way, right? So you can sort of see that some things were the things that were done, you can consider done and subtract them, and then you can come up with, okay, these are the things that are still remaining. And then you can see what of those things were actually delivered in Jakarta 11. And again, what sort of is on the way but isn't done yet. And also the things that sort of are still gaps, in some cases, long-standing gaps, frankly speaking. So let's take a look at Jakarta 11 in that context. So the add schedule annotation was delivered in Jakarta Concurrency. And this is actually one of the things, the old things that were in EJB. So if you want to use that schedule before EE10, you had to use EJB, right? So now you don't have to. You can use @schedule in any CDI compatible bean. But there was a few things that weren't done, and we'll talk about that in a moment, including things like messaging and doing more with regards to making the things that are locked in into EJB available in CDI. So one of the things that are sort of en route, we can envision probably is going to be done, is something called the roles allowed annotation. It's a declarative security annotation. Similarly, across the platform, we want to see CDI being adopted as a programming model in many different places, and there's actually quite a few gaps. These are the identified gaps that we have so far, as you can see. So one is, the Jakarta REST still uses this @context annotation that basically is the same as @inject. Really, we should be just using @inject everywhere. And that work has been sort of being discussed for a long time now. It didn't happen in Jakarta E10, almost happened in Jakarta E11, but not. And looks like it's now going to be done in Jakarta E12, hopefully. Right? So that work didn't happen. It's en route. What did happen, and we'll talk about in a moment, is better alignment with CDI in Jakarta persistence and Jakarta concurrency. Now, the old timers, Jakarta persistence is JPA, right? So one of the things that happened in the JCP to Jakarta Eclipse Foundation transformation is we got rid of those cryptic acronyms like JPA, right? So now things have more descriptive names like security, concurrency, persistence, so on, right? As opposed to JPA and JTA and so on, those acronym kind of things that a lot of people found confusing back in the day. Okay, so in terms of Java IC alignment, this has always been an important thing, right? So Java EE has always adopted its own APIs and took up the changes that have inevitably happened, the important innovations that inevitably happen in Java IC. So this time around, it is records. So there was a few changes in the specifications to make use of records, and similarly virtual threads, right? So those are the two key changes in the Jakarta 11 timeframe that happened in the Java SC side of things. Bootstrap API for messaging did not happen, right? If you look at Jakarta 10, we finally have a Bootstrap messaging for REST now. We could have similarly something for messaging. We'll talk about that in a moment. Now, one of the nice things that actually did happen in Jakarta 11 is the modernization of the TCK, or compatibility test kit. Now, the compatibility test kit is basically what you use as an implementer to say, yes, I have implemented Jakarta specifications. And believe it or not, this TCK is ancient. I mean, it was like there's stuff in there from Java 1.6, believe it or not, and it hadn't been updated for a long, long time. So one of the things that happened in the Jakarta timeframe is actually modernizing that TCK to use modern, believe it or not, things like Maven and JUnit and Archillion, as opposed to the really old way that the TCK really was. So I think this was actually an important bit of work that is almost done now with Jakarta 11. In terms of sort of standardization gaps, so things that are available in a non-standard way, one of the key things that happened was now you can use an in-memory identity store. I'll talk about more of this in detail in a moment. Things that didn't happen but are sort of on the way is JWT alignment and some things that didn't happen. One of the things that I'm very happy about is we did make good progress on deprecations, on removing things that are, or getting ready to remove things that are just old, right? It doesn't make sense to keep moving these things forward in a platform that is supposed to be forward-looking. So in this case, in Jakarta 11, I'm happy to say SOAP was removed, JAX-WS, XML was removed. So this is JAX-P. Corba support was removed. This is like Corba is like from the 90s. I don't even know how many people even know what Corba is these days. Removed that one. There was another sort of odd annotation, managed beans, that was introduced in Java E6 that never actually took off. So that is what deprecated this time. I'm hoping that we are on the path to also deprecating EJB, and we're making incremental progress. So, for example, doing @schedule, or allowing the ability to inject the persistence context via the CDI mechanism. This is all towards basically making it such that somebody that is using Java Jakarta today does not necessarily have to use EJB. They have another option, namely they can just use CDI as a component model. Now, as I mentioned, there are a few new specifications that have been in the making for a while, right? In fact, this is sort of holdover from Jakarta E10. These are things like repositories, standard for NoSQL, standard for MVC, configuration, gRPC, and so on. So a lot of that is sort of in flight, and I'll talk a little bit about that when we get to more of the details. But I'm happy to say at least one of those new specifications actually did happen. As I mentioned, the first new specification since Java EE8, and there's Jakarta Data or repositories. So that's at least a bright spot, and actually one of the more significant changes that happened in Jakarta E11. So taking a step back, at a higher level, these are what you can say are the themes for Jakarta E11. So first and foremost, the release date was supposed to be actually already happened, right? It should have been done in fall. That was what the projected objective was. Then it slipped to December, and looks like it's not going to be quite done even yet. So frankly, personally, I'm hoping it's going to be done in January, but let's say Q1. So for first quarter of next year, let's hope that we actually have a Jakarta E11 release. We can all keep our fingers crossed that that's going to happen. The baseline has changed, right? So the baseline used to be 11 and 17. Now the Java SE baseline is 17 and 21, meaning that at the minimum, all runtimes must support Java SE 17, and some of them, if they choose to, and probably most implementations will, in fact, a lot of the implementations already run on Jakarta E21, can also use Java SE 21 instead. Now, as I mentioned, what that means is there's few changes to take into account those updates in Java SE, namely adapting to records, adapting to virtual threads, removing the security manager. Security manager is one of those sort of low-level APIs that probably most people don't know what it is. So that was removed in Java SE 17. So as a result, across the board, a whole bunch of specifications actually removed their dependency on Jakarta, the Java SE security manager in some way. So when you look at it on the books, there's quite a few updates in specifications. A majority of them are just, we removed the references to the Java SE security manager. In terms of updates, there's a few, right? So, and we'll talk about these in greater detail. So persistence, concurrency, CDI, validations, these are the changes in net. Probably the biggest set of updates are in persistence. The rest of them, there's hit or miss, right? There's a few changes here and there, but not a sort of overwhelming amount of changes per se. Already talked about Jakarta Data, already talked about deprecation, and I've already talked to you about the TCK modernization that was long overdue and finally looks like it's going to be done in Jakarta 11. So that's at a high level what's in Jakarta 11. Okay. Pictorially, this is how it looks like. If you're unfamiliar with it, basically Jakarta EE has these profiles, right? So if you do it by profile breakdown, this is how the changes look like. Again, when you put this out and you say, oh, looks like a lot of updates, but actually not really. A lot of these updates are, for the most part, very small changes here and there that most developers would probably not notice, or changes like, oh, we updated the Java SE version, or we removed the security manager implementation. In net, probably, what I mentioned to you is probably the at a high level what the really some more substantive changes actually are. Regardless, this is how it looks like at an even higher level graphically if you lay out what actually changed. Okay, so now let's begin our tour of sort of the high-level changes or notable changes in each of the specifications. And like below the bar here, I'll talk to you about the stuff that is identifiable and has been identifiable for some time but didn't happen. Right. So Jakarta persistence is actually in Jakarta E11 is actually one of the most significant amount of changes that happened are in Jakarta persistence. And then, as you can imagine, this is one of the things that actually touches a whole bunch of Java developers. So these are the changes. First and foremost, you can now use Java SE records as embeddable classes. I'll show you an example of this. This is a really nice thing if you want to begin adopting sort of the newest Java SE features. Similarly, there's now built-in support for instant and year as types, as recognized types by Jakarta persistence. Although Java SE has not deprecated yet, I think it's a very good thing that Jakarta persistence actually has deprecated the old datetime APIs. So things like Java util date and Java SQL timestamp, all of those things, and similarly the add temporal annotation, those are all deprecated. So basically, the Jakarta persistence team is sending you a signal that it is time to move to the new Java Data APIs, which actually, other than instant and year, pretty much all of the types were supported by Jakarta Persistence as of Jakarta EE10. Now, for those of you who certainly are SQL fans or feel like, okay, if you do JPA, you're missing out on this SQL function, well, there's good news for you. There was a whole bunch of like these SQL type things that were added in Jakarta EE11 with Jakarta Persistence. I'll let you sort of list out and explore what all of these things are. I think they're important if you need them, but probably a little bit on the niche side. But regardless, all of these are now available to you in Jakarta Persistence. One of the things that actually is very important in terms of not needing to use EJB anymore is this ability to inject the entity manager and the persistence context via the CDI annotation into any CDI bean. I'll talk about this in more detail in a subsequent slide. Another quite nice thing is being able to configure the persistence context via Java. Right? It's still not as nice as, for example, I'll show you an example later on of being able to modernize configuration altogether, but at least now you have at least another option of, if you don't want to use the persistent XML, you could at least maybe do Java-based configuration. The things that were not done is, potentially making the persistent XML completely optional. I think that's doable, and also potentially, adding JCache as a second-level cache provider. So embeddable records, I think fairly self-explanatory. I'll just show you a quick example of how it looks like. Let's say you want to use an embeddable address. Well, you don't have to use a POJO anymore, Java object anymore. You can just use a record, right? Just like that. It's as simple as that. This one is important because prior to Jakarta 11, if you were to inject an entity manager, that entity manager would basically be non-thread safe. So what that means is you better inject the entity manager and use it in a place that is thread safe. And the only place that is EJB, used to be only EJB. What this change does is that it actually allows you to inject the entity manager into any CDI bean and also attach a scope to it. So one of the scopes you could attach is a transaction scope. And transaction scope happens to be thread safe. So what that means is if you do what I am suggesting in this code example, basically you can inject the entity manager into a CDI bean and use it in a completely thread safe way, just like, by the way, you could in Spring. Spring does basically conceptually exactly the same thing. This is the reason they can use Jakarta Persistence in a Spring bean without having to worry about things like concurrency. Okay. So speaking of concurrency, Jakarta Concurrency actually had a few changes, right? A few things that are still left over. And again, this is more along the lines of sort of making EJB unnecessary, making using EJB unnecessary in the Jakarta platform. So these are, I'll start sort of in reverse. The two things that didn't happen is at lock annotation. This is again sort of EJB specific thing. If you want to use it, you can only use it in EJB. Basically declarative thread safety. And the other thing that EJB does sort of in a non-standard way is concurrency throttling. So this is another thing that could be done in the concurrency spec. Now, in terms of what was done, one of the interesting aspects of it is adapting the whole platform to virtual threads. So in terms of this, really, there was this minor change. I'll talk to you about that in a moment, of making managed threads, managed thread resources, making those work with virtual threads. But actually, the broader work is for the runtimes themselves to adapt virtual threads as a runtime mechanism, as opposed to the sort of standard thread pooling mechanism instead. So that has happened to some extent, but not to a great extent, right? So Quarkus kind of sort of supports it. Helidon actually does. They can completely, you can switch off your all of your thread model to virtual threads, but largely the other runtimes, to my knowledge, really have not. They've done some experimental work around this, but at least we now have this one change. One of the things that did happen that again goes towards sort of using EJB unnecessary is this at schedule annotation that was introduced in Jakarta Concurrency. The other nice thing that happened was, believe it or not, a lot of the concurrency usage patterns, like executor service, for example, if you defined it, you can only inject it using this old school add resource annotation. So now you can use CDI to do that using add inject. Okay, so this is how that looks like. So if you were to use a managed executor in Jakarta EE, now you used to be you've been able to do this for a while actually in Jakarta E10 onward, is define it using this annotation. But now what you can do is you can say virtual equals true, and when you do that, underneath the hood, this managed executor will be using virtual threads as opposed to heavyweight sort of native threads, right? But one of the things you'll notice is that this thing was introduced. Virtual threads is a Java 21 innovation, but you can use Jakarta EE 11 in either 17 or 21, right? So the way this works is that it's sort of optional, if you will, right? So if you do this and your runtime in your runtime you're using Java SE 17, it basically will ignore it, right? But if you are running it in a Java SE 21 environment, it'll try to give you a virtual thread instead. So it's sort of like best effort, if you will. Okay, so this is how the add schedule annotation looks like. There's some room for improvement here. It's not quite a replacement to EJB add schedule annotation yet, but it's well enough on the way. Similarly, if you're a Spring user and you see this schedule annotation, its usage pattern will look a little bit more cumbersome than what it is in Spring, but at least there is something you can do that is would allow you to use something other than EJB if you want to make use of declarative schedule management. Okay, in Jakarta Security, there was a few things that happened. So Jakarta Security actually declaratively allows you to use databases and LDAP. So that work happened as of Jakarta E8 and Jakarta E10. And OpenID Connect, by the way, the other thing that you could use at OpenID Connect. That's another change that happened in Jakarta E10. But the big gap that remains is JWT. So JWT support is in microprofile. There was some debate as to how to handle this, but it's a common scenario to use OpenID Connect and JWT in the same application. So basically what they did was they created this microprofile bridge specification that was supposed to solve this problem. And on the Jakarta EE side, really just have a mechanism where it can make use of whatever's in microprofile bridge specification and microprofile JWT, primarily by allowing for multiple authentication mechanisms at the same time. So this work the initial work for this has happened in Jakarta 11, but not on the microprofile bridge side. So it's still a gap from that perspective. And the other nice thing that happened is in-memory data store. I'll show you that in a moment. Things that didn't happen that would have helped us get away from EJB even faster is making things like roles allowed and run as available in CDI as opposed to having to use EJB absolutely. Okay, so this is how in-memory identity stores look like. So again, there's identity stores for database, OpenID Connect, LDAP, and now you have this way of basically having usernames and authentication and authorization mechanism built into your application. So this is what this is about. I wouldn't recommend using this in production, but it is very handy for prototyping, development, and testing. So this is now included in Jakarta 11 in Jakarta Security. Okay. Jakarta messaging is one of the things that used to be a very important part of Java EE. Right? And if you think about messaging, the first thing you would think about is JMS or Jakarta messaging. I'm sad to say more and more that's not really the case, right? So I think in order for Jakarta messaging to become relevant again, you need a serious revision of it. And there's all of these changes that we did, that was always under discussion in the JCP and Java EE timeframes, but hasn't happened yet. There hasn't been a revision of Jakarta messaging since Jakarta 8, and this is, I think, long overdue. So these are the sort of changes that, as the ambassadors, we've identified for some time. So one of the things is replacing MDBs with a more modernized equivalent annotation in CDI delivered through Jakarta messaging itself. creating a lighter version of messaging that actually makes more sense in cloud native cases. A lot of the stuff that's in JMS is actually fairly dated and doesn't actually make a lot of sense in terms of the use cases these days. So it absolutely makes sense to create a lighter version of JMS. There's been a long-standing need for creating a Bootstrap API, so you don't actually always need to use Java EE in order to use JMS. You could be using it in a Java SE environment, and there's no way to do that in a standard way. It's always some non-standard hack to do that, so that's another thing that could be done. The protocol where a JMS provider and a server and a client talks to itself, that's proprietary. So that's actually not necessary because now you have something called AMQP that does just that. It basically defines a protocol between a client and a server for messaging. So again, if you were to modernize Jakarta messaging, one of the things you could do is make it more interoperable. So allow JMS providers to basically be used from outside of Java environments, for example, by introducing AMQP interoperability. So I'm going to just show you a quick example of what we mean by modernizing JMS. And again, this hasn't happened in Jakarta 11. No work has been done for Jakarta messaging actually in a long time. But this is how it could look like, right? So you could have this nice abstracted annotation that actually makes consuming messages a lot more powerful and a lot more simple, right? So you could be just getting the payload, and maybe if you wanted to the headers, those could be done in a declarative fashion. You could finally standardize things like receiving batches of messages, ordering the messages in some way, introducing declarative standard retries, retry delays, dead letter queues. These are all things that are in message event means in a non-standard way. Pretty much all providers support something like this, but not in a standard way. But you could do that as part of modernizing JMS. Similarly, if you were to have a sort of a very simple way of bootstrapping JMS in a Java SE environment, you could do it in this way, right? So this is how a standard Bootstrap API could look like. Again, something that has been discussed forever now, but just hasn't been implemented. So Jakarta Data is one of the things that actually did make it, right? So what is this? It is basically, if you're familiar with Delta Spike Data or the Spring Data JPA module, that's basically what it is. So you don't have to handwrite your repository or if you like DAO anymore. So the idea here is that you created an interface that describes how your DAO or repository should look like, and then it'll be automatically generated for you. In theory, Jakarta Data right now works with Jakarta Persistence, but it could also work with Jakarta NoSQL. So here's a quick example of it. I won't have time to dig into it too much, so I'll just let you take a look at this. And as I said, I'll share the slide deck with you. So you have your JPA entity, or might be Jakarta NoSQL entity if you're using Jakarta NoSQL, and then again you have your interface. It defines sort of what you want to do with your data. It could be just CRUD methods, save, update, create, save, update, delete, or it could have a rich set of finders, right? Either simple finders like finding by a particular field, or perhaps even a more complex query. And you don't have to handwrite this basically anymore. You could essentially more or less deal with all of these things in a more declarative fashion. Okay. So MVC, I'm not going to go over this too much. I'll just show you a brief code example of it. It is a sort of an alternative way of dealing with server-side templating, right? So as opposed to JSF, which is basically, I would say, Model 3 MVC, right? You really only write the model and the view. The controller is taken away from you altogether. This is sort of an inversion of that, where you do write the controller. The controller, in most cases, is just Jakarta REST, right? And then you do some very simple mapping, like attaching a view to it, and then injecting a model, and then populating the model. This is not going to be part of Jakarta EE. No, this is actually all done. Actually, Jakarta MVC has had a few releases, but it's not included in the platform. So it's not included in Jakarta 10. It's not included in Jakarta 11. And in my opinion, that's the way it really should be, right? Because these we're at a stage where not a lot of server-side development adoption has slowed down. So adding this as yet another thing, I don't know that it's very helpful. So another one is Jakarta NoSQL. This is again a mature specification. Has been for a little while, has been done for almost done for a little while actually. Another thing that my friend Octavius is trying to help standardize, but it's not part of the platform again. Right? So I'll take a look at, I'll let you take a look at the details of that, but it kind of looks like that. The entities look very much like JPA entities, and then there's a templating mechanism. It looks a whole lot like JPA actually, very similar to JPA. But the only difference is it varies by taxonomy. Right? So if you're using a key value database or a document database, the API varies a little bit. So it has actually several different flavors of APIs in there to deal with different types of NoSQL databases. Jakarta configuration is a very important one. So this was actually this specification was started in the Jakarta EE 10 or before Jakarta EE 10 actually finalized. So the basic idea here is to externalize application configuration and also to modernize application configuration across the platform altogether. It's both of those things. So basically, it's the idea that you don't need to, you can do all this configuration in XML like we now do, or Java for that matter. Instead, you can read your configuration from things like property files, maybe YAML, maybe Java environment variables, or system variables, right? External sources, external to the application, more or less, external to Java. And that these configuration sources could also be configurable and extensible. So for example, you should be able to add a jar that says, okay, now I want to read my configuration from Kubernetes secrets, or I want to read it from some kind of secure cloud storage like Azure Key Vault or a NoSQL repository, or even a relational database for that matter. And be able to use it in some sensible ways. And I'll give you some examples of what I mean by that. So there's three principal characteristics of that. Now, the thing is, this work, again, was one of those places where it sort of has overlap with microprofile. So microprofile has had microprofile configuration that does some of these things, but it does it in a microprofile specific way in the microprofile namespace. So you can't really use it in Jakarta EE directly without introducing weird circular dependency, because microprofile already depends on Jakarta EE. So this was subject for much debate. There was even a public vote for this, and everybody was very clear that they just wanted, this functionality moved from microprofile and adapted to Jakarta EE, right? So by adapting it, here are the three patterns that this would enable, right? So one is, injecting your configuration values into Java using an annotation. The other one is basically doing the configuration all together, doing Java configuration, like things like what we do in WebXML or stuff we do in persistent.xml, doing all of that stuff externally, right? Maybe through application properties or just system properties or what have you. So here's an example of that. This is another way that Jakarta configuration could be used. Yet another simple one is, even if you are using XML or you are using Java configuration, you still should be able to reference some part of your configuration from outside your application, like this environment variable example that I have. So Jakarta configuration sadly has not made much progress. I hope that was not true, but it is, right? And it hasn't made much progress for many years now. I do hope that this will finally make progress in Jakarta EE 12. This is one of the things that I think will significantly modernize the entire platform. So aside from all of that, there are a few other changes that happened when I talked about, okay, these are all, it looks like there's a lot of changes. These are all small changes here and there. Okay, so these are some of the smaller scale changes that happened across many different specifications. So one is, as I mentioned before, the security manager was removed from a bunch of different places. The manage bean annotation was removed. But one of the nicer things is I gave you an example of Jakarta persistence. But actually now Java SE records is supported by a whole bunch of other specifications that already made changes so that you can use records with them. So these are examples of Jakarta validation, CDI, and EL. So all of these made that change. There's a nice, you can now specify priority in CDI producers. For those of you who are deep in CDI, it's kind of a nice, like a smaller grain but important feature. Now, a few things that didn't happen. is one of the things that's a big miss actually is not adding JavaSC support in JSON binding. So that's actually one of the places where you would want to use records. And it was just barely missed in Jakarta 11. I hope it's going to get corrected very soon. Again, we've been waiting for this add context in Jakarta REST to be deprecated and finally use CDI everywhere. It didn't happen. Again, this time, hopefully it'll happen next time. And another one is this, being able to needing to use XML in something like Jakarta Batch was pretty cumbersome. And again, it's been in discussion for a little while, but didn't actually happen. So here's an example of validating records. I'm going to breeze over this since we're running a little bit short of time. But basically, you can now validate records just like you can validate POJOs using Jakarta validation, just like that. One of the things that didn't happen, and literally this example is from JBeret, which is the Red Hat implementation of Jakarta Batch. So it would be just so easy, to just copy and paste and standardize this in Jakarta EE so easily, right? But this is basically allows you to now, if you want to use the batch, Jakarta Batch, you have to define this XML file called batch XML, and it's very cumbersome, and you can't change it. It's since it's XML, it's sort of hard coded, right, in your application. What you can do instead is do this, right? Is do the same kind of configuration but in a Java way. Okay, so these are just some of the things, as I told you before, some of the things happened, some of the things that didn't happen. I do really believe that like an average developer that's a little bit more motivated can actually contribute these changes. This is one of the reasons why we did this Jakarta stuff in the first place. So beyond, if you don't want to do that work, and which I really do believe you can, right? There's a whole bunch of other stuff that you can contribute to in Jakarta as well. That's much easier. So for example, Bean Validation and CDI have their own websites. I don't see why every single specification in Jakarta shouldn't have their own website. There should be a website for Jakarta REST. There should be a website for Faces and so on. Jakarta EE examples, again, some of these examples at this point are really old. I don't even know how many of them even show you how to use Jakarta E10 and Jakarta E12. Very neglected project. Right? This is another thing where you could get involved in and add more useful examples. The Jakarta tutorial, thankfully, is in good shape now, right? So, but that can always use more help. The Jakarta Starter is in good shape. You can use the Jakarta Starter these days with Jakarta EE, so that's something you could potentially help out if you wanted to. There's some work there. Same thing for Eclipse Cargo Tracker. So these are some of the places where you could contribute. So what are the at a high level, what are the ways of contributing? Well, the ways of contributing is you can get on a mailing list, you can get onto a project, you can actually make a change to documentation, specification, or TCK. It's very simple. All you need to do is sign one online thing called the ECA, and that's about it. You don't even need anything else. If you want to be a committer, there's some things that you need to do later on. And if you need any help with any of this, you can always engage an ambassador. It's very easy to do, and you can even reach out to me personally, and I'll help you. So Jakarta 11 is almost here. It's a modest release in the end, but it does introduce some important things, even for people that are not using necessarily a Jakarta 8 runtime. As I've said a few times now, one of the reasons we did all of this is to increase net new contribution. And that's where we need your help. And your contribution could be as simple as evaluating things or simply adding to your voice to say, hey, this is an important change that didn't happen yet. Why isn't it happening? Please make it happen in Jakarta 12. That alone is a contribution. And of course, if you want to do anything beyond that, I believe it is possible. So you can consider getting involved yourself. So I'll just wrap up here. I'll leave you with some resources in the end, and I'll also share the link for this presentation deck as well in the chat. So Jakarta 1 just happened. It has a bunch of different nice recordings of all things related to Jakarta EE. Similarly, there is a Jakarta Tech Talks that's even more in-depth. It actually happens sort of on a monthly basis. That also has a bunch of recordings in there that you can check out. If you join one mailing list, I would ask that you join the Jakarta community mailing list. You can do that in the list if you don't want to join any of the others, more in-depth ones. And another things you can very easily do is follow the official Twitter handle. I think Jakarta is even on Blue Sky now. If you're on Blue Sky, you can either follow it on Blue Sky or X to stay up to date with the technology. So that's about it. I appreciate it. I hope this was helpful. I'm going to now do a little bit of Q&A with the little bit of remaining time that's left, and I'm also going to share a link to this deck so you can take a look at it in your own time. And of course, you can reach out to me, anytime. Doing these talks is honestly just an excuse for me to get in touch with you and get in front of you and let you know that, hey, I'm here to work with you and talk to you if you see the value in this technology. So that's about it for today. Again, thank you for having me. And
thank you, Reza. Thank you, Reza. Interesting topic. Jakarta 11 will come with many features available. We have a few questions here.
Yeah, tell me.
Okay, the first one is about. Okay, playing in the screen. Frank Ayala.
How do other technologies? I'm reading it out loud just for the recording. How do other technologies like microfile, Quarkus, Spring Boot integrate and compete with Jakarta in a modern development landscape? So I'm going to give you an honest answer to this. The reality is they do compete, right? So so in other words, you can use these other things instead of Jakarta EE, right? Instead of using pure vanilla Jakarta EE, you can use a microfile runtime that adds a bunch of stuff on top of Jakarta EE. Quarkus does something very similar. It takes bits and pieces of Jakarta EE and then adds its own stuff. And then Spring, of course, is probably one of the worst of those. Basically, it takes really small bits and pieces of Jakarta EE, uses it under the hood, and then has its own APIs. So it's your choice. I'm not going to tell you these are not good options, especially these days, right? Hopefully I made it clear that I do think that Jakarta EE is not competitive and is behind in some ways. So you can use those technologies if you need something bleeding edge. But at the same token, if you're writing a very simple application and all you're doing is a CRUD app or a RESTful web service, honestly, Jakarta EE just is more than good enough. And one of the nice things about Jakarta EE is that you're not bound to a specific vendor, you're not bound to a specific runtime. You're free to pick and choose. You're not sort of locked into one specific thing like you are in many cases with some of these things like Spring Boot or Quarkus. So that's the differential. It's a question of, do you really need a whole bunch of bells and whistles? And if you don't, then okay, you can pick something that is maybe a little bit slower moving these days. I hope it's not going to be forever, but slower moving now, but at least gives you some more flexibility in picking and choosing.
Right. Thank you. We have another question here. What is the key difference?
What are the key differences between Jakarta messaging and other messaging frameworks like Kafka and RabbitMQ? How do they integrate Jakarta applications? So Kafka and RabbitMQ do not directly integrate with Jakarta applications. You can integrate them using Kafka. You can use microfile reactive messaging to do some integration with Kafka. RabbitMQ, you really cannot at all. So RabbitMQ, if you want to use it, basically you'll have to use its own APIs and maybe use it with CDI. Kafka is honestly not comparable with Jakarta messaging in some ways. So functionally, it does some similar things. I'll give you my honest answer. I think Apache Kafka is far more complicated than Jakarta messaging ever should be. If you primary reason, honestly, like really when it comes down to it, the only reason you should use Kafka is if you have very, very high throughput needs. If you don't have that kind of very high throughput needs, we're talking about, honestly speaking, thousands of messages per second. If that's not the scale that you need, honestly, you're just fine with Jakarta messaging, and it's a much simpler API to deal with. RabbitMQ is sort of neither here nor there. It's the big differential between RabbitMQ and Jakarta messaging providers is that it is AMQP compatible. That really probably is the only foundational difference between Jakarta messaging and RabbitMQ.
All right, great. We have a last question. Franklin Vidal, regarding the Jakarta configurations, are configuration files necessary?
In most cases, yes. I haven't seen many applications that at the bare minimum, you need to configure your data source. So you need to configure what most applications are at least database-driven applications. So at the bare minimum, you need to configure that. You need to configure things like, hey, where's my REST endpoints going to be talking to? At a more realistic applications, you need to do a lot more configuration. You need to configure thread pools, monitoring. There's no getting away from application configuration. It's a very important part of any kind of enterprise application, whatever your platform is.
Perfect. Thank you so much, Reza, to join us. Have a good day. Have a great night. Thank you again.
No problem at all. My pleasure.
See you guys. Hasta luego, chicos. Nos vemos. Bye bye.